Hello. In this lesson, I'd like to go over some examples of applying fundamental theorem of calculus part 2 to find the area underneath the curve, which is the curve between x-axes. We did some examples in class, but let's start with a simple example. I'm going to just work on the odd numbers for the moment. If we have more time, we can work on some even number. Odd numbers starting from number 1. We have integral, which is to find the area underneath the curve. That's from 1 to 3. From 1 to 3. And we use this example to explain what it means. Okay, what it means, and we go from there. Derivative dx. Okay, this is to find the area underneath the curve of this function, which is f of x. Well, you don't have to introduce that function. It's a curve between 1 and 3. Okay, between 1 and 3. So x from, let's see how that curve goes, right? From 1 to 3. So point 1, let me make some adjustment. Oops. And here we have -4 to say 7. Let's see if that works. 1, 2, 3. Obviously, we need to make some adjustment again. Say 10. Let's see if that works. 1, 2, 3. Okay. You can see that 1, well, x equals to 1. Okay. I'm just going to make a little bit adjustment so you can see better. 1, 2, 3. For this function, when x equals to 1, okay, so I'm going to explicitly introducing this function to explain to you the geometric meaning of it. Okay, so for x equals to 1, you see this on this forte sign 1, 2, 3. That means we want to know the area underneath the curve between 1 and 3. So what is f of 1? F of 1, we plug in 1. So this is 1 times 1. And that should give us 1 plus 2, that's 3. Minus 4, that's -1. So this point is going to be 1, -1. So we're going to put that point on the graph. Okay, so there's the dot. I can make it red. Make it red color. Okay. And the other point is f of 3, right? So we're going to have f of 3. So here, x of 3, 3, 3. And that will equal to 9 plus 6 minus 4. That's 15 minus 4 equals to 11. Okay, 15 minus 4, that's 11. So the point is 3, 11. So we're going to plot the other point on the curve. We make it a red dot. Okay, that point doesn't show because I need to adjust the view. There we go. So what does this integral means? The meaning of this integral is to find the area, okay, is to find the area between the curve and the x-axis. That is, okay, so from this point over here, right, we draw a vertical line, everything between the curve and x-axis. Okay, so to mark the area, we are going to mark this little area here. Okay, this little area here, this area actually is going to be negative. And all of these areas. So this integration is going to give us the sum of this two shaded area. Because this piece is red and this other piece is positive, one is negative area, positive area. So obviously the positive area is much larger. So that's going to be the total area underneath the curve. So that's what we're looking for. According to Fundamental Theorem of Calculus, part 2, okay, which is right here. So we're going to follow this theorem to identify our area. Okay, so what do? This is how we do it. When you actually work on these questions on your homework, you don't have to draw this graph, but you need to understand what it means. What does the whole thing means? Okay. On exams, you don't necessarily have to draw the picture, but you need to understand what it means. Okay. So when we try to find this area, we can apply these properties, right? The area of, the integration, the definite integral, the area of the sum is the sum of, the area. So we can separate, right? So we can do this integration piece by piece. Okay, so we have x squared dx plus, and the next one is going to be the integration, right, of a 2x dx minus 4 times dx, right? Which we can take the constant outside. So we're applying some of these properties here. And next, according to Fundamental Theorem of Calculus, we just have to know an antiderivative of each one of them. Okay, so what is the antiderivative of x raised to the power 2? Well, that's going to be x raised to the power 3 divided by 3. Okay, so that's the antiderivative. Evaluate at the endpoints, f comma b, f of b subtract f of a, capital A. So this function will be evaluated. Okay, let me see if I should have a long bar to do that. Okay, well, that looks really ugly. Never mind. Just this bar, okay? Evaluate at a 1 and a 3. Okay, so this is how you write it. And the next step would be, okay, of course, we're not finished yet, is you can leave out the 1/3, and inside the bracket, inside the parentheses, you plug in the b, which is 3 here, f of 3, f of b, which is 3 to the power of 3, subtracting 1 raised to the power 3. So that's what we're doing the integration for just this part. The second part, plus 2, the antiderivative of x is x squared over 2. Okay, as a matter of fact, here 2 and 2 will reduce, right? So I just have x squared. And then it will also be evaluated from 1 to 3. Okay, so the next term will get that 3 put in x squared, that's going to be 3 squared, subtracting 1 squared. So we're applying that fundamental theorem of calculus part 2 one more time. Subtracting 4. What is the antiderivative of 1? Basically, this is a 1, okay? Well, it is x, right? We had a 4 in front of it, so 4x, and evaluate it from 1 to 3. Oh, oops. Okay, so this minus 4, this piece should go there, sorry. Okay, so minus 4x, right? On this part, we just have to do the parentheses, plugging in 3 into x, or 4x, but we factor the 4 out, so we get 3 minus 1. So that's how we show work. And these are new notations, so I went through and more carefully. And now it's just arithmetic. It's just arithmetic. Let's see what we get. Excuse me. 1/3 multiply 3 to the power 3 is 27. 27 minus 1, that's 26, right? Plus 3 squared is 9. 9 minus 1 squared is 8. Minus 4 times 2, that's 8. That's 8. Okay, 4 times 2, that's 8. All right, so 8 minus 8 is 0. So finally, we get 26 divided by 3. You don't have to transform it to mixed number, but if you do, no problem, no problem. So this is the whole process of solving this kind of questions. Okay, so let's look at, we've done a couple others in the class, so let's look at maybe 23, right? Let's look at 23. I attached this indefinite integral table here, which is antiderivative table. Okay, well, antiderivative and indefinite integral is almost the same, but indefinite integral is the whole family of antiderivatives. So indefinite integral is a more general form. Okay, so let's look at 23, and this time we're integrating, okay, from 1 to 9. So 1 to 9. And the function is root x dx. Okay, so this time we can go a little faster. And it's area underneath the curve between 1 and 9. Okay, area underneath the curve between 1 and 9. So you can go straight to the antiderivative. Okay, you see x, root x is half. Half is the exponent, right? So you're gonna use the power rule. So 1 plus half under 1, and x raised to the power of 3/2, and evaluate from 1 to 9. And there you go, right? And you simplify, right? Over here, we're getting, the denominator is going to be 3/2. Flip over 2/3, 2/3, right? X raised to the power of 3/2, we plug in the 9, so we're gonna do a little carefully. So first 9 raised so this piece x will be substituted by 9, and then we're going to substitute it by 1. Almost there, right? We apply Fundamental Theorem of Calculus Part 2. And what does that equal to? Algebra. This is all even, it's arithmetic, right? 9 is 3 squared. 9 is 3 squared, right? So this part, oops. Oh, I'm sorry. So here I'm going to write it as the following way. I'm going to parenthesize the 9, and 9 is 3 squared. Okay, so the two exponents multiply, and 1 to the power 3/2 is just 1, right? So in this piece, the next step would be these two exponents multiply, 2 and 2 reduce, is going to be 3 to the power 3. So this is going to be left with 3 to the power 3. And that's just 1, okay? Now, move it, we get 27 minus 1 is 26. So 2/3 multiply 26. What does that equal to? It just equals to 3 under 26 times 2. That's 50. 52. Okay. That's it. Finished. Let's look at like 27, right? What do we do with 27? 27, we have a product form. We have a product form, but there's no product rule for integration though. There's no product rule, nor quotient rule for integration. And this time it's from 0 to 1. And we got u plus 2 multiply u minus 3 and du, right? And what can we do? FOIL. Okay, so just FOIL. FOIL, we are getting all of this, and the 2 being FOILed, so what do we get here? Inside, so we get u squared, 2u, positive 2u minus 3u, so minus u minus 6, right? And then we're gonna do it like we did with the previous example, just like this one. Okay, so let's quickly finish. Find antiderivative for u squared. That's u to the power 3 power rule divided by 3. You can also write it this way, okay? You can write it this way, u squared over 2. You can separate it, you don't have to separate it. You know, in this case, I didn't separate it. So all of these together, we're going to evaluate at 0 and 1. You can write it that way, okay? Now we're gonna plug in 1. So all of these in the bracket, we're gonna plug in 1 as if we're doing capital F of B. So this u will be replaced by 1. Subtracting capital F of A, all of it in the bracket, u will be replaced by 0, 0, 0, right? Of course, the latter is 0. Let's see what we get in the end. We get 1/3, subtracting half, minus 6. Okay, and operate, we get common denominator. Okay, get common denominator, and that's going to be 2 over 6 minus 3 over 6 minus 6, right? I didn't do that minus the common denominator for -6 because we have, in the first part, we have a -1/6. -1/6 minus 6, that's just going to be equals to negative of 6 and 1/6. Finished. Okay. Check out another question. 39 is the arc, the antiderivative is the arctangent. Okay, so let me show you anyway. Let me show it to you anyway. We got integration symbol, but we integrated between 1/√3 all the way to √3. There. And the function in consideration is 8 over 1 plus x squared dx. You see, we have all these properties here, right? We have all these properties for integration. We can bring out the constant, right? We can bring out the constant, so 8 can be brought out. And the antiderivative of 1 plus x squared under 1, that's arctangent. So we can just have 8, right? Arctan of x evaluated at 1/3. It's a little bit crowded. All the way up. Oops. Up to √3. Okay, when you write it on paper, you may like to leave some space. Okay, we have 8. Okay, so we're going to apply the fundamental theorem of calculus right here. Capital F of B subtracting capital F of A. So our capital F is arctangent, right? So we're going to take this piece, right? Put it in the bracket if you want. The parentheses work too. Subtracting when A capital B is substituted by √3, excuse me, and the other one is going to be substituted by 1/√3. And both are special values. Both are correspond to special angles, right? So we're going to continue this operation. We have 8. We can change to parentheses. Arctangent √3 is pi/3. Arctangent 1/√3, that's pi/6. Pi/6, right? And we do a little operation making common denominator, so that's 8, right? Inside the parentheses, the common denominator is 6. And so this is going to be 6 under 2 pi. So near the end, we got 8/6, okay? 2 pi minus pi is pi, so this is a pi. And 8/6, the common factor is 2, so we have a 4 pi/3. 4 pi/3. You see, primarily algebraic. Okay, algebraic. Next one, I'm looking at 43. Okay, because 43 we have 2 pieces, piecewise function integration. In that case, what do we do? Okay, for piecewise function, right? The interval has different rules. We're going to use this property. Okay, I'm going to use this property, separate the intervals. So let's see how we're going to separate it. Okay, so we have, right, integration from 0 to pi. 0 to pi, and the function is f of x dx. But how is f of x defined, right? So here we are told that f of x has different rules on different intervals. Okay, so we're going to write it down. We're going to copy that question. Okay, and there are two functions. All right, between 0 to pi over 2 is a sine x. If 0 is less than or equal to x and less than pi over 2. And the other rule is cosine x. If x is between pi over 2 less than equals to x less than equals to pi. All right, so we have two rules. So when we work with this integration, we are going to separate it. Okay, so how do we express it? So I'm going to show you how we express it. We're going to have integration. Okay, this integral will be separated into two parts. One is from 0 to pi, right? So this is going to be 0 to pi over 2. So then it's from pi over 2 to pi. Okay, so these two integrals will be separated according to property number 4. Here I can still put f of x. Okay, even though on this step you could okay, dx plus, okay, don't forget dx. Okay, don't forget dx. So the other one is f of x dx. All right, okay. Or you can go straight to the next step, because between 0 to pi over 2, the rule of the function is sine x. And in the other interval is cosine x. Right, so cosine x. So there you go. So this step can be skipped. So be careful, you have to mark the intervals properly. Okay, to mark the interval properly. And then we go about to fundamental theorem of calculus. Right there, part 2. Okay, so what do we get? The antiderivative of sine is cosine, a negative cosine. Okay, evaluate it at 0 in the bottom, pi over 2 on the top. Okay, plus the antiderivative of cosine is sine, right? And evaluate it at pi over 2 to pi. Okay, so next we're going to plug it in. When we plug in, we can leave out the negative sign outside. Okay, so it's the cosine pi over 2. Oops, pi over 2, which is 0, subtracting cosine 0. On the second part, it's going to be sine of pi, subtracting sine of pi over 2. Okay. Cosine pi over 2 is 0. Cosine 0 is 1. So negative 1, another negative. So it's going to be positive 1, the first part. Plus sine pi is 0. Sine pi over 2 is 1. So minus 1. Minus 1 is equal to 0. Is equal to 0. Okay, so these are, when we have piecewise functions, when we integrate, that's how we do it. That's how we do it. You divide, you separate the rules for separate intervals. All right. To verify, you just take a derivative of the right-hand side to get it. If you get the left-hand side, you got it. Okay. Here are a bunch of indefinite integral. Here are a bunch of indefinite integral. I think I'm going to make a different recording for the indefinite integral. Okay, so thank you for watching.